Alright, so we're going to continue our path of stoichiometry, and our question of the day today is to determine the empirical formula for a compound that's used to ignite explosives. It has 24.74% potassium, 34.76% manganese, and 40.50% oxygen. Now your answer to this is going to need to be uploaded on Canvas. So pause here and complete this calculation. So what are we seeing with this chemical reaction? We are seeing one atom of iron reacting with one atom of sulfur to create one molecule of iron sulfide. Now, it's important to realize that these are atoms, not mass units. So can we do this chemical reaction? Well, we couldn't really do it where we could see it. That's just it. We would have a hard time trying to get just one atom of iron because it's microscopic. So, not really. We have to perform it many times larger in order to be able to see it. So, to bring it to the macroscopic scale where we can see it, we perform the reaction 1 mole times larger. So, we have our reaction. So, if we do this 1 mole times larger, we could write it with the atoms, just like this, or we could convert it to the moles. So, that coefficient could be atoms, or it could also be moles. And yes, everything we do in chemistry is going to keep going through moles. So, ask yourself this question. If we have 10 grams of iron, how many grams of sulfur do you need? Pause here, think, and come back. Okay, so most are probably going to say something like 10 grams. The only problem is, remember, those coefficients, even though it's one component of iron to one component of sulfur, that's not masses, that's molecules. Each molecule has its own atomic mass. So it would not, in fact, be 10 grams. So it's important to realize that this 1 in the coefficient is moles or atoms. It is not a mass unit of grams. So if you have ever traveled abroad, we have to convert our money. So in the sign that you see here on the right, you see that a taco is $13. But that doesn't mean American, U.S. currency. That is pesos. So you have to be careful and make sure that you're using the correct unit and looking at your equations in the correct way to truly understand what's going on. So when we look at our ratio, all quantities have to go through moles. There's a reason we have the mole map. Everything needs to go through a mole. So let's look at a sample problem. So we have carbon dioxide. And we can make this carbon dioxide commercially by heating chalk, which is calcium carbonate. We want to know how many moles of carbon dioxide can we produce from 3.05 moles of calcium carbonate. So, what do we do? Well, included in your spiral is a 5-step guide that you need to follow every single time we are doing these kinds of problems. So this guide right here, as we blow it up, step 1, we need to write a balanced chemical reaction for the problem. That reaction unit can't just be thrown into a corner. You have to still use that in class. You still have to use that on your homework. It is still there with you. We are then going to take the amount given in the problem, and everything has to go through moles. That is the only unit that chemical reaction understands. This is a mole map step. You have to go through moles. If we have a limiting reactant, which we're going to get to what that means. We do step 3. Otherwise, we skip it and go straight to step 4, which is to set up a ratio. We're going to put the chemical we want to figure out on the top, the chemical we have on the bottom, and that's going to get us our ratio of what we're going to get. And then we need to convert the final amount. It's starting in moles typically, and then we either need to convert it to grams or liters or atoms. Whatever we are asked to do for the problem, this is our mole map step. So this is what we have for our stoichiometry concept map. This is our recipe of how to solve this problem, and we are going to be using this frequently. So here we go. Step 1, writing a balanced chemical equation. We have calcium carbonate, and it's going to decompose into something. So we go back to our reactions guide, and it tells us that if we have a metallic carbonate, it's going to decompose into the metallic oxide and carbon dioxide. So calcium carbonate is going to decompose into calcium oxide and carbon dioxide. Now if we check, we have 1 mole or 1 atom of calcium on each side. We have 1 atom or mole of carbon on each side. We have 3 oxygens on each side, so we are balanced. So in case you're wondering what calcium carbonate looks like, it's limestone. Okay, so here we go. We have our chemistry recipe, if you will. The next thing we need to do is to take what we were given and convert it to moles. This is our mole map step, but it was already done for us. We're told we are starting with 3.05 moles of calcium carbonate. So we're good there. One step down. We do not have a limiting reactant, so we don't even need to look at step 3. Problem solved. So let's move into step 4. We need to set up a ratio from that chemical reaction. So what that reaction says is that I can create 1 mole of carbon dioxide for every single mole of calcium carbonate I start with. It is just like using a recipe in the kitchen. So here we go. I know I have 3.05 moles of calcium carbonate. That is going to make 1 mole of carbon dioxide for every single mole of calcium carbonate that I start with. I can cancel out my units, and that gives me 3.05 moles of carbon dioxide. That's what we're asked for. Answer is in moles. We are done. That is the final answer. Right now, what you need to do is to go look at those 1-step problems. You have a 1-page assignment of 1-step problems. Work them. Keep in mind, this is the type of steps you're going to be doing. So let me know if you have questions, and I'll do 2 steps in a second video.